All right, let's get right into it here. 11.1 areas of parallelograms. So we're going to cover perimeter and area. You should be very familiar with what perimeter means. But just to review, it means you add up all the sides, okay? So in the last quiz and all the assignments you did last week, the last couple days, we're focusing on circles. So perimeter of a circle was called circumference, and then an area was pi r squared. We covered circles first because they're unique. Parallelograms, you know, it's that whole umbrella of rhombi, squares, rectangles, and then we'll do trapezoids last. Basically, now we're doing all two-dimensional area of polygons. Is pretty much what we're getting into right now. So from chapter 6, which you guys did back in January, a parallelogram is a quadrilateral, so it's got 4 sides where the opposite sides are parallel, opposite sides are congruent. You've got consecutive angles are supplementary. You've got opposite angles are congruent. You've got diagonals bisect each other, all those different things. And then we have specific stuff for squares, rectangle, and rhombi. So just keep all those ideas in mind because they are expected for you to know. So if you're still struggling with stuff, let me know and I can keep posting some kind of useful tips on that. So I'm going to jump into what I would have had you guys do to kind of discover what the formula would be. So try to envision in this one that this light blue triangle here actually started over there. So try to visualize that and then that this wasn't there, okay? This whole shape would be a parallelogram where this length is 2, this vertical perpendicular length here would be 1, and the entire base down there would be 4. Now, I would have had you guys discover the formula and kind of guess at it. That's what all of these are over here. These are previous year's worth of just students' suggestions. So the correct answer is there, but I would have done in class is I would have had this triangle here and then drag it over here. Now, what shape is this? I'm hoping you're saying to yourself, rectangle. And then think about what the formula is for a rectangle. Though we haven't totally covered it, you did it in middle school. You probably learned it as length times width. We're going to actually use it as base times height. So here's where you definitely want to have either paper out or take a screenshot or something, but write it down, star it, bold it, whatever you're gonna do. The formula for all parallelograms is base times height. So that, again, that applies for a parallelogram, that applies for a rectangle, that applies to a rhombus and a square as well, okay? Now the key here is that the base and the height must be perpendicular. Now base does not mean bottom. All right, I know it kind of looks like it here, but it doesn't have to be. It could be rotated, so keep that in mind. The key there is you want to find the 2 lengths that are perpendicular to each other. We use the words height and base interchangeably. So here's an example where, like, this one looks kind of goofy, but I'm going to actually put the base down here, and you're like, well, where's the height? You can actually just drop it down. I call that from chapter 4, if you guys remember from triangles, I called it the Pride Rock triangle where Simba and Rafiki are up here and Simba dives down, okay? So that would be like your height. It doesn't actually touch it, which looks kind of weird, but that is still gonna be the height. And then, you know, in a rectangle it'd be here and here, a square would be here and here, and then in this, what appears to be a rhombus, it could be this length with that, it could be this length and that. It just depends on what you have in the problem. So I'm going to show you guys 5 examples, which you're going to also use tomorrow too. So I'll post this video under tomorrow's stuff as well. So in this one, I'm giving you a parallelogram where this length here is 12, this is a 30. Because it's a parallelogram, I know if this is 30, so is that. If that's 12, so is that. So I'll just do perimeter first because it's easy. Take 12 plus 30 plus 12 plus 30. Bam. Perimeter, 84 inches. Donezo. Okay. Again, you can feel free to pause these at any point, okay? I know I go quick because I'm just trying to keep the videos efficient, but you can totally pause it and go back if you need to. Now, area. Again, it's base times height. Here's where you want to look, that perpendicular length. We don't know the height. Okay, pretend you don't know the height, okay? You would have to find it. Well, the fact that I gave you a 60-degree angle here is the key, is that tells you that this triangle is a 30, 60, 90, where opposite 60 is the long side. I know it doesn't look like it, but it is. You got to trust the angle measurements here, which means this guy down here is actually the short side. So you take 12 divided by 2, that gets you the 6. and then take 6 times root 3, that's going to get you the height. So ultimately here to find the height, it's going to be base, which is 30, times the height, which is 6 root 3. So I wrote that right here. So the exact area is 180 root 3, which is also approximately 311.8 square inches. So rewind that if you need to. But again, the key there was to look for that 30, 60, 90 and figure out which one is the long versus the short side, okay? This one is kind of like that one I just showed you 2 slides ago, where you're going to have to kind of envision the height not technically in the parallelogram. So we know this length here is 4, which means this is 4. This is 16, which means this is 16. So we know the base can either be the 4 or the 16. It doesn't actually matter, but you're going to have to figure out what the height is. So the way I did this one, I used 4 as the base, and I dropped from here straight down. Okay, I made it a perpendicular length, and that's going to be our height. The nice thing here is if that's 135, you just do 180 minus that to get you the 45. It's a linear pair, which, ooh, look at that, 45, 45, 90, which is something you should remember from the previous chapter. So we can take 16, which is over here, okay? 16 divided by root 2 will get you this length and that one, okay? I did all that rationalizing stuff over here. This right here is the exact height, 8 root 2. That's the length here and here, though that's not actually relevant. So we know the area then can be 4 times 8 root 2, which is here. Now, let's say you really wanted 16 to be your base. Totally fine. You could actually draw the height here, like connect an imaginary line right there. Turns out this angle, yet again, is going to still be 45. So it would actually end up being 4 divided by root 2, which means your height becomes 2 root 2. Turns out 16 times 2 root 2 is exactly the same thing. So it's not wrong if your gut was to make 16 your base. It's totally fine. So the exact answer there is 32 root 2. And the approximate nearest 10th answer is 45.3 square meters. Now, I didn't ask to find perimeter, but if I did, it would just be 4 plus 16 plus 4 plus 16. Shh! Stop it! Sorry. The dog is being annoying. Okay, on this one, so we've got like that lighter yellowy color in the middle, and that green region is around it. These are 2 rectangles. Technically, the bigger one's actually a square, but that little guy in the middle there is a rectangle. So I want you to find the green region. Okay, if you want to try it before I explain it, pause it, take a look at it, but I'll keep going. Essentially, it's going to be the area of the big minus the area of the small, which is what this is saying right here. So I did the area of the big guy first. So 20 times 20, 400. Area of the little guy is 12 times 9, 108. So it's just 400 minus 108, which is 292 square centimeters. If you're thinking like, when is that necessary? Think about, if you're looking at painting a room or something like that, and you have to subtract, you obviously wouldn't paint like a window frame or wallpaper a window frame. So if you want to figure out the total area you need to paint or cover with wallpaper, you have to subtract the areas you don't need. So like a doorway, a window frame, things like that. So that's kind of where this would play into like the real world aspect. Now these last 2, almost done. So in this guy, I'm going to zoom in a little bit. Okay, because I know the font's kind of goofy on this particular one. All right, there we go. Okay. So we've got 18 here. We've got a 4 here, 4 here. All right, well, let me come back. I'll come back to that actually. I gave you the 4. I gave you 15. It's kind of hard to see, but I did give you the 6 there. I gave you 10. I gave you 8, and I gave you 19. The other ones, you had to kind of think about this problem as 2 ways you can do it. You can figure, this particular problem is actually easiest to figure out the whole thing and then subtract off this little guy here and then subtract off this little guy there. So what I first did was I wanted to figure the perimeter. That's just what I did first. So I wanted to know what all these missing pieces were. So if you're wondering where this 4 came from over there, 19 is the whole length. Subtract off the 15, that's where this 4 came from. Not because that's a 4, it's just a coincidence, but it's 19 minus 15. That's where the 4 came from. Let's see, this 8. So I did 4 plus 18 because I want to know what is this entire height? What's this entire length here? In this case, 22, which means this is 22. So if you do 22 minus 6 and then minus 8, that's where this 8 is coming from. If you want to redraw this, guys, please do. If this isn't, and again, you would have had guided notes if we were in class, but we're not. And the last guy here, you can assume that if this is 10, so is that. I'm not trying to trick you here. These are all right angle measurements, so you can assume that. So perimeter is just add up all the sides, okay? Please make sure you can do, I know that sounds silly, but like actually type it out, okay? Don't just don't just read and watch what I'm doing here. Actually make sure you can physically type that. Now for area, so I did 19 times the 22, okay, which is something. I'm not gonna lie to you, I don't have it written down right now, but 19 times 22. And then I figured out the area of this guy, which would be 16 because it's 4 times 4. The area of this guy, which is 8 times 10, so 80. I took the whole area minus 16 minus 80, and you're gonna get 322. And the very last one, so I can zoom in a little further because this one's a little smaller of a picture. Okay. So let's see, that's better. Make sure you guys can see it okay. All right. So we know I gave you this was 17. I gave you this was 6. That's 15, 5, 8, and 7. So those are the only lengths I gave you. This particular problem is actually easier to break it up in chunks. So if we were in class, I would have asked you guys like where you would have drawn them. In the past, I've had some students, draw it across here. They draw this straight down. Like, there's no wrong answer there. You don't want to create a gazillion rectangles. You want the fewer, the easier it's going to be. So I just drew across here and drew there just to have 3. You don't need more than 3. You definitely have to have at least 3. You can't do it with 2. So I figured out, so 5 times 8, this little guy here is 40. I did 7 times 17 to get the 119, and then 15 times 6 to get the 90, and then add them all up to get 249 square feet. I didn't ask for perimeter because it's fairly straightforward, but it would be 5 plus 8 plus 7 plus 17 plus 6 plus 15. You'd have to add in another 6 here, another 8 there, and then figure out this guy right there, which would end up being 17 minus 5, so that would be 12. Okay, so I will post this video for today, and I'll go ahead and post it for tomorrow too, that way you don't have to go back and forth. But see Google Classroom for the assignment. It is going to be from the textbook. Email me or call me on my Google Voice number if you have questions. I will talk to you guys soon.